Hello, and welcome to this Data Structures and Algorithms lab. This is the second lab, but it's numbered as the third. I don't know why. And before we get started, I'd like to say a few things about failure and just if you're. I failed many times in the past, and I think every failure is a step forward. And there are many businessmen who failed in their first businesses. So if you really like something and you're not great at it, don't worry. By practicing, you can get better. And there is also a very nice podcast about this. It's called Mind Architect. In season 3, episode 7, you can see how failure can improve everyone's lives. All right. Now, coming back to our stuff, in this lab, we'll have 4 parts. In the first part, we'll do a short recap on linked lists. In the second part, we'll do some exercises, and then we'll talk about circular lists and doubly linked lists. The last parts are more theoretical, and we won't spend too much time on it. The main part will be the exercises. Okay. So, before we start, let's do a short recap. Last week, we talked about linked lists. And in linked lists, we basically store multiple numbers. Actually, it can be general. They don't have to be numbers, but we only work with numbers in this lab. So we have a node structure. Each node, each list element contains a key, a number, and a pointer to the next node. If we look in the computer's memory, this is how the computer sees this list. So at address 150, we have the first node. At address 300, we have the last node. And at address 700, we have the middle node. Here, these numbers are quite random. I choose them at random. They would actually be really big because the memory has a lot of variables. And the address is the kind of the variables number in memory. Okay, and as you see, in the memory, the elements don't have to be in the same order as in the list. And that's because each element is somewhere randomly in the memory. We don't care where, because the elements are linked by the next pointer. So if the first node has a link to node at address 700, we know the next one is 7. And then we go at 300 and we know the next one is 12. And the null here at the end means we have nothing after it. Also, for each list, there are 2 important things, the head and the tail. You can optionally also store the number, the int count, the number of elements, but that's optional. Even if you don't store the count, you can find it using the head. You can start from the head and increment it by 1 with each element you see. All right. Now, these were the linked lists we talked about the previous week. And before we get started, actually, to get started, go ahead, open this link, and here you have some code. This code is for what we did last week. We have 2 data structures, the print function, insert last, and main. So go ahead and copy this code. The link is here. Also, you can find this lab in the description of the video below. So you can go ahead to slide 4 and click on the link if you don't want to type it. Alright, and copy and paste it in code blocks or whatever you're using. I'm using Visual Studio Code. Let's go here. And create a new project or file or whatever you're using. And paste the code in there. And here we have a small task to use these functions, insert last and print, to insert the numbers 10, 7, and 12 and print the list. If you successfully implement this, you should see in the console 10, 7, 12. The only thing you need to do is inside this main function. Okay, put a pause on the video and try to do it yourself. We'll come back to it afterwards. Okay, so to do this, use insert last of list and 10. This basically inserts this 10 in the list. Then we again insert last list 7 and insert last list and 12. And finally print the list head. And if we run it, let's see. Okay, it does some stuff. Okay, and it successfully prints 10, 7, and 12. So we're all good. If you see this in your console or terminal, that's perfectly fine. And also, if something goes wrong, just email me or write a comment below. I'm here to help. Alright. Now that we have a starting list, we can go ahead and do some exercises. And before doing the exercises, I want to recommend you a few useful websites, which are LeetCode. This is a very useful site when before you're applying for a job, because it has a lot of problems that are common at technical tests, which are before your first job interview. And here you can sort by difficulty. If you're just getting started, you can start with easy problems and see if you can get them right. And after that, you can go ahead and apply for jobs. The second useful website is Glassdoor. And this is useful because it contains ratings for each company. So if I want to look for a company online, I'll enter here its name and I'll see what their employees say about that company. And finally, there is this is a Romanian website where you can find interview questions for Romanian corporations. So if you're trying to find a job at a specific company, you enter here the company name and the city, and it will search for people who applied to that company and tell you what their interview experience was. And you can also enter your personal opinion on interviews here. So these are the 3 websites that I think are useful for those who are trying to find jobs. Okay, and today we're gonna do 2 exercises from LeetCode, from the linked list tag. So we're only doing linked list exercises. I don't think this is the most common interview question. I think it's quite rarely used. The most common one is, what projects have you worked in the past? So if you have the option to choose the projects you work on during your university time, just try to do something that you like, because that will help you in the future to put on your CV, and also at interviews you can talk about it. And yeah. Okay, sorry for the long rambling, but let's get back to the point. We're going to do these 2 exercises. So the first one is finding the middle of a list. So here we have the head. We're given the head and the tail. I don't think we need the tail, so only the head is required. Optionally, you have this count field that you know. And what's the task is to find the element in the middle of the list. If the number of elements is odd, the middle one is the one in the middle. But if the number of elements is even, they're asking you to find the second middle one. So we can consider both of these in the middle, but we'll only choose this one. So the task is to find the middle of a list. Try to put a pause and think about it, and try to implement it yourself. If it doesn't work, send me a message or email. We'll come back to it in a few moments. Just pause and try to do it. All right, welcome back. So if you're trying to find the middle of a list, I think the most straightforward solution is to use the count. Sorry, let's pick this one. So here, the count, the number of elements is 3. And we should also look at how many steps do we need to take forward. So here, we'll always start from the first one and move to the right a fixed amount of times. So here we make number of moves should be 1. We only go once to the next. Here count is 4, and the number of moves, we want to make 1, 2 moves. We don't care about the indexes here. This is index 1, 2, 3, or so on, because in lists you can't do something like list of 3. This is not possible in lists. So that's why we're looking at how many steps we need to take forward, because that's something we can do. Now, let's see how we can take this number of moves from the count. If count was 5, if we had one more element, the number of moves would also be 2. So for 4 or 5, it's the same. I think the the formula for the number of moves. Actually, the number of moves is count divided by 2. If you know the count, you can divide the count by 2 and make that number of moves. This isn't the only solution. If you have another solution that works, don't worry, it's perfectly fine. So if we go ahead back to the code, we can declare a function that returns the middle of a list. We have list. Here we don't need a pointer because this middle function won't change the list. You can put a pointer, but it's not necessary. So we can take here a pointer starting from the head. We start from the head. And we can use a for loop. It's more than list count. From 0 up to count over 2. Or from 1 smaller or equal to list count over 2. Because we want this many moves. Sorry, here it should be dot. We put arrow if it's a pointer or dot if it's a plain struct without pointer. All right. It still doesn't like it. Try to list. Oh, it didn't see. It's okay. And here we do p equals p next. Basically, this moves p to the next one. And finally, we can return our p. So we start from the head, we go count over 2 steps, and in each step, we move the pointer to the next one. And in our main function, if we print middle of list, let's see. Try to run it. Okay, it gives an error. It just gave an error. Where was it? Here. So here list is a pointer, but in middle list is a plain structure. So you can either put a pointer here or put a star here to get the list itself. Let's try it now. Okay, now we get a warning that here we print a number, but this is a pointer. So this returns the whole node. What we want is only our key, the node's key. And now if we try to run it, let's see what we get. All right, we get middle 7. So it works. Let's try with an even case. We added an 11. Now it should return 12. Let's see. Yep, middle 12. So it's okay. All right. So that's all with this first exercise. If you have any questions, don't forget, put a comment or write me a message. Okay. Now the second exercise is to reverse a list. So if we have the list 10, 7, and 12, we want the list either to change the initial list or create a new one with 12, 7, and 10. So 12, 7, and 10. Now pause this video and try to figure out a solution by yourself. There are many solutions. Any one of them will do. Okay. Welcome back. And here there are two main solutions. In the first one, we take each element from the initial list and insert it at the beginning of the next list. So if we start from this one, we can do it like this. So we take the 10 and insert it in a new list like this. This is list 2, let's call it. So we create a new list and insert the first one. And then we insert the second one with insert first, which inserts before the first element. And it should also move the head like this. And then take the next one and insert it at the beginning. So it should take this guy and put it here. And also move the head. So the reverse will take each element from first list, from initial list, and insert first in a second list. Another approach, which might be easier, we'll see later, is to actually not create a second list, but modify the initial list. So if we look here, the first element will have null at its next. The second element will have the first one as its next. It will be something like this. And the third element will have its second one as the next, so it will look like this. And after that, swap head with tail. And you have the reverse list. Both approaches are alright. Whatever you choose, it's fine. The complexity is the same. There is no perfect solution. Okay. So I'll start with the first implementation with two lists, and then we'll see the second variant. So we have a list. We'll create a function. Initially, we'll make it void and then see reverse list. So we take a list, and actually, in case we do a second list, we can return the new list. So we can create a new list first. Let's call it new list. new list. So right now we have a secondary list with head and tail both pointing to null. Like this. So both head and tail are initially null for the second list. Then we'll do something like take a pointer, a node star p, which starts from the initial list head. And we go while p different, while we didn't reach null, we go to the next one. Basically with this, we go through the whole list. But before moving on to the next, we should insert first in the new list p key. So insert the number from here in the new list. And finally, we can return the new list. Now let's see how we do the the insert first function. Insert first. It won't return anything because it only changes the list. Here the list structure changes. The head and tail and the count can change inside the function. So we put a pointer. And we also have a key, the number we want to insert. Okay. I don't know why it's complaining. Let's run it once. Okay. This will disappear. It's just a bug. Okay. So we want to insert something at the beginning. And the first step is to create a new node, an empty node, like this one, an empty node. So we do a malloc. We have a new node. The node's key should be the given key. And it's next. So let's say we have this list and we want to insert something. The next should be the previous head. The head of the list will be the next of the new node. So new node next equals list head. And this also works in case the list was empty. So if the list was empty, its next will actually be null. And here we put the key. Now, if we insert an element at the beginning of the list, we should also move the head to it. So list head becomes new node. So if the list was empty, it will be like this. The head will be the new node. If the list wasn't empty, it will come like this and move the head here, and the arrow would be here because of this line, this list head. The next is the old head. Okay. And we should also increment the count if you have this variable in your code. But in the special case when the list was empty and we moved the head to the new one, the tail is wrong. It's still at null. In order to fix this scenario, because we would like the tail to come to the new node if the list was empty, but we wouldn't want that to happen if the list had some elements. So if we already have a tail and insert something at the beginning, we don't want the tail to change. So here we put if list tail is not null, list tail becomes new node. So with this, we also have the insert function, the insert first function, which adds a node at the beginning of a list. And the reverse function is complete. We just take each node and put it at the beginning of the list. And in the main function, we can go reverse list, get the reverse of our list. Here we put a star because this one is a pointer and this one isn't. And if we print the reverse list, starting from its head, let's put a new line here. And see, we have reverse list 11, 12, 7, 10. 11, 12, 7, 10. So it worked. Okay. The other way to do it, let's call it reverse 2. But this one was when we changed the arrows. And also we changed the head and tail. So in this case, since the head and tail change, we need the pointer. Okay. Let's delete this. So for this to work, we need three things. We need to know the previous, the current, and the next. We'll see why we need each one of those. So initially the previous is null, and the current starts from head. And the process works like this. So with current, we move through each element. And for each element, we change its next to the previous element. So in here, we changed its next to null. But when we do this, when we change the next to null, to the previous, we lose track of the next element. So before doing this, we should save the next node in a variable. Then in here at the current, put the previous. And then we can use this next pointer to move the current here. And also, before we move the current, we should move the previous to the current one. So we have the previous. Here, and then we move current here, and then we move next here. And then again, we change the next of the current to the previous one. We change it like this. Then we move previous to the current and current to the next. Then we change next to the next, which is null right now. We change the next of current to the previous, like this. Move the previous, move the current to the next, and that's it. So we start with previous null. We start with current list head. And we also take the next as current next. Okay, and we'll go while current is not null. We take next equals current next. So going back. Back. Okay. So we have the current here. We take the next one here. And as we said, at each step we say current next becomes, the next of the current becomes the previous one. So then we put here null. Then we move previous to the current. We move previous here and current to the next. And I think we can also move this line here. Next equals current next, because initially the next is correct. So after we do this, the links are all reverse, but we need to do one more thing. We need to swap head and tail, because the new head is the previous tail and vice versa. So we take an auxiliary node as list head, then list equals list tail, and list tail equals auxiliary value. Okay, this is the second way to reverse a list. And if we want to try it, let's reverse 2 of our list. This time we don't put a star because it's a pointer in the function. And this time we print reverse list number 2, and since this modifies the initial list, we print the same list. Okay, here I forgot an F. Let's try again. Oh, it crashed. Holy cow. Okay, so when current becomes null, if we try to get the next of null, it will crash. So this should come up here because we want to get the next only while current is not null. And then this becomes optional, but let's keep it. Let's try again. And now we get the reverse list as is the same result, but it modifies the original list. So that's good. Okay. And that would be all with reversing a list. And now we got two more small things to talk about. The first one is doubly linked lists. And here are the linked lists we used so far with head, tail, and each node had a pointer to the next. But at doubly linked lists, each node has two pointers, one to the next and one to the previous. So the first one has one next and one previous, the second one has next and previous, and this one has a next and the previous. And in memory it would look like this. Here is the addition. We have two pointers, next and previous. Now, what are the advantages of having also next and previous? The first advantage is that it's easier to delete a node, especially the last one. Because when you delete a node, you need to go to its previous and remove this link, to remove the link from its previous. And if we wouldn't have the previous node, in case of the last one, we would need to go from the head step by step until the previous one to the last one, and that would be slow. And another advantage is that you can traverse the list in reverse order. I don't know why you would do that, but you can do it. But there's also a disadvantage compared to singly linked lists, and that is memory consumption. Since we use two pointers for each node, it will take up more space. So that's a disadvantage. As far as I know, doubly linked lists are more used in practice than singly linked lists because of its advantage, and the memory cost is not so significant compared to the contents of the list, because usually you don't store numbers, but you store big structures inside. So usually the cost isn't that big to put one extra pointer. All right. We'll skip from the exercise. And the last part is for circular lists. And here, the idea of a circular list is that the last element has its next equal to the first one. And this way you get like an infinite list. Now, it changes a bit the code because if you want to check if you reached the last one, you shouldn't check if next is null, but you should check if next is equal to the first. I don't know if these are used in practice. I haven't seen them. And for doubly linked lists, it's the same idea, but last one is linked to the first one, and the first one has its previous, the last one. And this is all. If you have any questions, don't forget to tell me. And also don't forget to upload your code that you did with the reverse and middle function. Make a zip archive and put it on Moodle at lab 03. Let's see. Here, lab 3 assignments. Upload here the code you have here. Okay, thanks for watching and have a nice day. Bye bye.